So in this video, we will talk about difference of squares, factoring by using difference of squares techniques, obviously used when we have difference of squares. So if you have a squared minus b squared, this can be factored as a plus b times a minus b. Okay. You can check that that's true. Just FOIL this expression here. A times a is a squared. A times negative b is minus ab. B times a is ba or ab. And b times negative b is negative b squared. Obviously, negative ab plus ab cancels out, and we're left with a squared minus b squared, what we had in the beginning. By the way, this expression, when you have a sum or difference and you're multiplying it by a factor that differs only by one sign, okay, we call that factor the conjugate of a plus b. Okay, so let's do a few examples. Let's start with a very simple one, x squared minus 4. Here you should check that we are talking about, obviously there is no common factor, right? You always start with that idea. Is there a common factor between these two terms? So this is not multiplied by a constant divisible or multiplied by 4, and here I don't have a factor of x. Okay, so there is no common factor. So the only choice so far in this review of pre-cal is that we can use the difference of squares, because this is x to the power of 2, right? And then you can notice right away that 4 is nothing else but 2 squared. So now x is my a in this formula, and b is 2, right? So right away you just jump into applying this formula. A is x, so you write x plus b is 2 times a, which in our case is x, minus b, and b in our case is 2. So there you go, x squared minus 4. You managed to factor it like this. X plus 2 times x minus 2. Part B, 2x squared minus 50. At the very start, be careful, we cannot apply difference of squares right away. Why? Well, first of all, although you can express both of these terms as squares, right, that is not going to be very helpful. So the first step that you do is you check whether there is a common factor. This is 2 times x squared minus 50, which is an even number, that means divisible by 2. Right? So you factor the constant 2, the biggest common factor, and you have x squared minus 25. And x squared minus 25 indeed is difference of squares, x squared minus 5 squared. There you go. A squared minus b squared is a plus b times a minus b, and here I have x squared minus 5 squared. So you copy the factor 2, x squared minus 5 squared, it's difference of squares being factored in the following way, x plus 2, so the sum of these two terms times the difference of these two terms. Okay, sometimes you're going to be asked to factor something like this, x squared minus 3. Okay, and 3 is not a perfect square, so the question is, can you continue? And sometimes you will need to continue. And here you have to observe that 3 can be written as square root of 3 and then the whole thing squared. And then you proceed just by, here a is going to be x, b is going to be square root of 3 in our case, so you can factor this as x plus square root of 3 times x minus square root of 3. Part d, okay, x to the power of 4 minus 1. Here we have to be a little bit careful, okay? First of all, 1 is always 1 squared, right? 1 squared gives you 1, okay? Now the question is, what squared gives you x to the power of 4? What squared gives you x to the power of 4, and that x to the power of 2. So now in this particular case, be careful, a is x squared, right? This whole thing is a, and this thing here is b. b is equal to 1 from our formula right here. So this ends up being x squared plus 1, a plus b times a minus b times x squared minus 1. Do we stop right here? Well, no, you have to factor it out completely, and as you can see, you have another case in which we can use difference of squares. So here you have x squared plus 1 times, so this is basically x squared minus 1 squared, so that's x plus 1 times x minus 1. Please don't get caught in this trap. Difference of squares can't, sum of squares can be factored. And then let's have another type of problem where we have to solve the equation x cubed minus is equal to 9x. Now in the first video about factoring, I told you that these kind of polynomial equations, you will be expected to solve them always by factoring. So first of all, let's bring everything on one side of the equation. So bring 9x on this side of the equation. That leaves us with 0 on the right hand side. Okay, now let us start factoring. First of all, what we can notice is that the common factor is x. So we are left with x squared minus 9 is equal to 0. And here, we said in the previous video, in the video about factoring polynomials, just by factoring the greatest common factor, you can find it on YouTube, that if a product of two factors is 0, then either one of them is 0. In this case, both factors can be 0, right? So either x is 0, either this factor here is 0, or this factor here is 0, or x squared minus 9 is equal to 0. This here gives us the first solution of the equation. X is equal to 0. You can plug it here and check. 0 to the power 3 is 0 is equal to 9 times 0 is 0. So 0 is equal to 0. Checks out. But now we need to continue. Again, be careful. Always solve polynomial equations by factoring. So can I factor this? Well, yes, this is difference of squares. And this can be factored as x plus 3 times x minus 3 being equal to 0. And again, the product of two factors is 0 when either one of them is 0. Let's check if both of these can be 0. X plus 3 is 0. For what value of x? Well, just bring 3 on this side and you get x is equal to negative 3. Or x minus 3 is equal to 0, or this factor, bring negative 3 on the other side of the equation and you get x is equal to 3. So this equation here, this cubic equation, x cubed is equal to 9x, has 3 different solutions. X is equal to 0, x is equal to negative 3, right? Negative 3 cubed is negative 27, is equal to 9 times negative 3, which is negative 27, or x is equal to 3. 3 cubed is 27, is equal to 9 times 3, which is also 27. So the idea here is that you solve polynomial equations by factoring.